Hi, this is our second video in which we're learning about how to find the area of a regular polygon. For example, you see a regular pentagon here. In the previous video, we looked at what a regular polygon is, and we also looked at the anatomy, so to speak, of a regular polygon, the radius, the apothem, and so forth. And then we also looked at how, we looked at a way of finding the area of a regular polygon by recognizing that from the center of the regular polygon to the vertices we can create congruent triangles. And so if I can find the area of one of the triangles, I can just multiply it times the number of sides, because that's how many congruent triangles I'd have. Multiply that area of 1 times, in this case, 5. If I had a hexagon, 6, and so forth, and that would give me the area of the regular polygon. But then we looked at how we would derive a formula for finding the area of a regular polygon, which was 1/2 times the apothem times the perimeter. So that's where we left off in the last video, and now we're going to look at using the formula. All right. So in example 1 in your note-taking guide, you don't see these black lines, but we'll see why they're there in a second. So in the diagram, we've got A, B, C, D, E, F. It's a regular hex, and so they're just kind of giving us one little easy step at a time how to use this formula. One of the things we're going to be able to need to do and find the area of a regular polygon is we're going to have to be able to understand some angle relationships. So that's what we're doing here. So for example, what's the measure of angle EGF? So we've already seen this once, but what we need to recognize is that's a central angle. These are radii because they're going from the center to the vertices. And so EGF is a central angle. And we recognize, okay, this hexagon with the radii, all the radii of the hexagon can be divided up into 6 congruent triangles. Okay, 6 sides. So you have a regular hexagon, so it can be broken up into 6 regular or congruent triangles. If it was an octagon, a regular octagon, then we would divide it up into 8 congruent triangles and so forth. So we have, again, we kind of saw this already, but we have 6 congruent triangles. We're being asked what's the measure of angle EGF, and since these triangles are congruent, all right, we know they're congruent isosceles. The radii are congruent and the sides are all congruent. So by the side postulate, all these triangles are congruent. And so again, these angles here, these 6 angles here, are congruent because they're corresponding angles of congruent triangles. And these 6 angles make up 360 degrees. So they're congruent, so we can divide 360 up into 6 equal parts, and that would give us the measure of angle EGF, the central angle there. So 360, whoops, hold on a second, whoops, did it again. 360 divided by 6 congruent angles is 60 degrees. So each of these central angles, like EGF, measures 60 degrees. So the second one is, what's the measure of angle EGH? Okay, so this is where we have to remember what we've learned about isosceles triangles. Remember, these are isosceles triangles, and this apothem is also an altitude. And remember, for an altitude going from the base of an isosceles to the vertex, it's also a perpendicular bisector, an angle bisector of the vertex angle, and also a median. So we just discovered that EGF is 60 degrees, and so this altitude is going to bisect that, so angle EGH is going to be half of that, right? So half of 60 is 30. Then the next question is, what's the measure of angle HEG? Okay, so we could answer that 2 ways. One, we could look at it, okay, this is a right triangle, and we just discovered that this is 30 degrees and this is 90. So 90 and 30 from 180, 90 plus 30 is 120, 120 from 180 is 60, so this angle must be measured 60 degrees. But I also want you to see it this way, okay, this is an isosceles triangle, the central angle is 60 degrees, base angles of an isosceles triangle, like angle GEF and GFE, base angles are congruent. So to find the measure of angle E or F, we'll call it, even though that's not correct, if that's 60, we could take 60 from 180, which is 120, and then these two angles are congruent, so half of 120 is 60. So really what we have here, notice, is 60, 60, 60. This, and for a hexagon, these congruent triangles are going to not only be isosceles, but they're equilateral. All, because how do we know that? 60 degrees, 60 degrees, 60 degrees. Remember, equilateral triangles have are equiangular as well. Okay, so again, these are things you're going to need to do in the process of finding the area of a regular polygon. Let's look at example 2. It says a wooden coaster is a regular octagon. So now we're dealing with an octagon, a regular one, with 3 centimeter sides and a radius of about 3.92 centimeters radius, center, vertex. What is the area of the coaster? Okay, I wonder if you want to take the challenge and pause the video and see if you can find this yourself. But remember the formula for the area of a triangle is 1/2 times the apothem times the perimeter. Okay? So I'll pause in a second in case you did want to stop and start. Try to get it yourself. Alright, so if I'm going to use this formula, I need 2 things. I need the apothem. Is that given? No, it's not. And I need the perimeter. Can I get the perimeter? It's not given, but do I have enough information to derive it? Yes, I do, because I have a side length that is 3. It's a regular octagon, so all the sides are congruent, so 8 times 3 is 24. Okay, so I'm missing the information that I need to find the area of this octagon. Alright, so what, I need the apothem. That would be, let me get a line here. Hold on a second. Alright, so first of all, let's just draw the other radii. Okay, so there's our isosceles triangle, and then we want the apothem. I'm not going to draw the right angle symbol, but that's going to be, perpendicular to the side going to the center. That's the apothem. We need to know this length in order to determine the area. How are we going to do that? Okay, we're going to use what we learned. Actually, do we need to do it in this case? We do not. I was going to say we need to use trig, but we're not going to in this case because we have 2 out of 3 sides of a right triangle. Alright, so what you see down here is this triangle cut out. Okay, and so we know the radius. Okay, the radius is given. It's 3.92 centimeters. Okay, so here's my isosceles triangle. This altitude creates a right triangle, and notice, okay, it's not only an altitude, but it is a perpendicular bisector and a median. So S is a midpoint of PQ, and PQ, remember, is 3 centimeters. So that's why you see the 1.5 there, because it's half of 3. So we have 2 out of 3 sides of a right triangle. We can use the Pythagorean theorem to find the length of RS, which is the apothem, and that's what we need to complete the information that we need for our formula. Okay, so let's look at how the note-taking guide says all this. So find the perimeter. They're saying you have 8 sides. They're all 3 centimeters, so that's 24 centimeters. And then find the apothem. Okay, the apothem is what they're calling here segment RS of triangle PQR. So since triangle PQR is isosceles, then the altitude, as we learned, also bisects the base. Okay, PQ. Okay, it's a median in a perpendicular bisector. So, all right. So half of QP is 1.5, and so QS is, they're saying, is 1.5 centimeters. So again, what we've already seen, now what they're taking us with is we have enough information to use the Pythagorean theorem to get RS. So that's what we need, the apothem. So when we use the Pythagorean theorem, all right, the way the note-taking guide is showing it is just all combined here. You've seen this before, but so let's call this A, and this is C because it's the hypotenuse. Actually, I should have called this A, right, for apothem. Okay, so we have 3.92 squared using the Pythagorean theorem is equal to 1.5 squared plus b squared. So to get b by itself, I would subtract whatever 1.5 squared is from 3.92 squared. That's what you see here. And then to go from b squared to b, I would take the square root. So this is all of the this is a summary of all the steps it would take to solve for b. And we find that b, which again I should have called a for apothem, is 3.622. Okay, so the length of RS is 3.622. So I now have the length of the apothem. All right. Okay, so now we have all the information we need to use our formula. We have the apothem, and we have the perimeter. 1/2 times the apothem times the perimeter, which is, when we multiply it all out, is approximately 43.5. Okay, so the area of the coaster is about 43.5 square centimeters. And again, we could have used the formula, or I could have found the area of just one of these triangles and multiplied it times 8, because we're dealing with 8 congruent triangles. Okay, so hopefully you caught on to that and you're about ready to do the assignment. Let's look at a different scenario. Alright, so in example 3 we have a regular nonagon that's 9 sides. It's inscribed in a circle. And again, we're given the radius, just like before. I thought maybe this would be a different scenario. Maybe it won't. Let's see, is that we were given the radius. Alright, yeah, it's going to be a little bit different scenario because we don't have a side length, it looks like. Find the perimeter and the area of the nonagon. Okay, so I mean, can't skip the step anyways. We got to have the perimeter in order to get the area, so they're not really giving us extra work here. So how can we find the perimeter? Notice all we're given is the radii. Okay, so this is a case where you see here we're going to have to use some trigonometry because we only have one side length. You know, in the other example we had 2 side lengths. So we construct an altitude, which is the apothem, and that creates out of this isosceles triangle 2 right triangles. And we can easily find the measure of angle JLK, right? Because we know that we have 9 congruent angles that make up 360 degrees. So 360 divided by 9 is 40. Okay? So we got a 40-degree central angle, then the altitude cuts that in half, it bisects it. So angle MLK or JLM is 20 degrees. Okay, so one of these angles is 20 degrees, and now I've got a right triangle, I have an acute angle and a side length, so now I can use trig to find this base. Okay, which would allow me to get the perimeter, which would allow me to get the area. So what I'll be doing is I'll be getting a half length, right? Because I'm dealing with the right triangle. This is a midpoint of KJ. So when I use trig, I'll get this side length here, and then I'll just double that to get the side of the nonagon, and then times 9 gives me the perimeter. Okay, so apothem LM, segment LM bisects the central angle, so that the angle KLM is 20 degrees. So from the 20-degree angle, I want KM or MK, and I have the hypotenuse. So what is that? Have opposite from the 20-degree angle, opposite over hypotenuse. So I'm going to use the sine ratio. So the sine of 20 is equal to MK over 5. Okay, that's like a variable. That's just like x. So what am I going to do to get this variable by itself? I'm going to multiply both sides by 5. And they're leaving it as 5 times the sine of 20. We'll talk about why in a second. All right. Now they're also finding the length of LM. Okay, so again, this is this triangle cut out. And that's where we see the 20-degree angle, this triangle and this triangle are the same. So now they're going, before they get the perimeter and the area, or before they go ahead and get the perimeter, they're getting the apothem, which they'll need for the area. Okay, so from the 20-degree angle, I want the adjacent leg, and I have the hypotenuse. That's cosine. So the cosine of 20 is going to equal LM over 5. Again, LM being a variable. So I'm going to multiply both sides by 5 to get this variable LM by itself. And we've got 5 times the cosine of 20. The book is leaving it like this because they're going to, I believe, put it in their formula when they're finding the area. Instead of getting an estimated value of LM and MK, they're going for precision or accuracy, so they're going to keep it as close to the exact value as they can by not rounding yet. Okay, because if we had to do 5 times the sine of 20 and the cosine of 20, we'd get some repeating decimal, irrational number, and we'd have to round somewhere, so we're losing a little bit of value. So this is to be more precise why they're leaving it in this form rather than an estimated form. All right, so now we're ready to find, I guess, the perimeter. S being the side length of the nonagon is what they're finding first. Okay. Let me stop here. I notice I've gone over 15 minutes, and if I go much further, I may not be able to upload this video. So I'm going to stop here and apologize in advance for stopping in the middle of something.